Hi guys, my name is Vanilin, and in the next couple of videos we are going to have a look at how you can use PyTorch Lightning to structure and develop your deep learning projects. Let's get started. So what is PyTorch Lightning? At least according to the official website pytorchlightning.ai, it's a framework for researching using PyTorch, and it helps you to scale your models or train your models and get rid of the boilerplate that is associated with using PyTorch to train deep learning models. So what this means for you, they have a couple of features or outline of what the framework can do for you. They have an example, and there is actually a very nice step-by-step tutorial right here, which basically shows you how you can convert some PyTorch code into Lightning code. And I'm going to show you in the next couple of videos how we can do that using a custom dataset. PyTorch Lightning is an open source framework, and the code is stored on GitHub. There is a very nice README file right here, which again can help you get a feel of what PyTorch Lightning is. And of course, you can use it for a lot of purposes, but in my experience and the experience of my colleagues, the people that I work with on a daily basis, PyTorch Lightning is really helpful when you want to train in device agnostic environment. So what this means is that you can train on a CPU, on a GPU, multiple GPUs or multiple machines even, and you can basically do that by changing a few lines of code, and it's really a few lines of code. You can also create a very well integrated models with TensorBoard. You can create model checkpoints and basically use the optimizer schedulers and the whole shenanigan using just a couple of lines of code. It integrates very nicely with the transformers library from Hugging Face, which is a great feature, and you can use it to basically everything, and it doesn't get in the way. What this means is that you can basically save your trained models and then use them from vanilla PyTorch or other libraries, which is again a great thing. So you can use PyTorch Lightning as a dev dependency in your project just for developing, evaluating your models. And in these couple of videos, we are going to go through a custom dataset. We are going to prepare a data module and then a Lightning module, which will basically contain the model that we are going to use. I'm going to show you how you can integrate everything with the Electra model, which was outsourced or published by the Google Brain team. And we are going to use a GoEmotions dataset, a dataset which is again published or open sourced by Google. And I'm going to go into what the dataset is right now. So in the next couple of videos, we are going to have a look at a dataset published by Google, which is called GoEmotions, and it's a relatively recent dataset, and it contains a corpus of curated comments extracted from Reddit, and those comments were basically annotated in a variety of emotion categories or a neutral emotion category. And as you can see, there is some summary statistics. We have a lot of examples, which is great. And there is basically a paper which is associated with this dataset. And the paper is called GoEmotions, a dataset of fine-grained emotions. And you can go through all of this. I'm going to open source or publish the notebook which we are going to write about. So in there you'll find a lot of references to the paper and the dataset. And let's get started with the dataset. Let's dive in what we need to have a look at it. So the first thing that I'm going to do is basically install a couple of dependencies, and I'm going to copy and paste those. So we are installing PyTorch Lightning, and this is the latest version, at least at the current moment. Then I'm installing the transformers library from Hugging Face, and I'm going to basically print out all of the library versions that we need. or that I'm currently using, so you can easily reproduce all of this. And it takes some time to download everything. So after we have this, I'm going to get some of the imports that we are going to use. And in here, we are basically importing Seaborn, Matplotlib, so for some visualizations, then pandas and patlib. I'm going to use the pat object or class from there. As you can see, the libraries are now installed on this Google Colab instance. And then I'm going to run through the imports from here. Next, I'm going to get the file which contains the complete dataset, and I'm going to unzip the data. So as you can see, these are the versions that I'm currently using, and we are using again the latest version of PyTorch, which is 1.10. And we have the zip file, which is currently stored, which contains the complete dataset, which contains 3 CSV files, and those are extracted in here. So this is the structure of our data. And to have a look at the data, I am basically going to read the 3 CSV files into a separate data frames. But to do that, I'm going to basically look for the files, and I'm going to use the path from patlib. I'm going to have a look at the CSV files, and this will be the file paths. So those should contain the 3 CSV files, which is correct. And then I'm going to create the data frames for each file. Yep, this should be better. So here I'm going to read the CSV file, and I'm going to append the result to the data frames. And the final data frame is going to be the concatenation of the 3 data frames. And I'm going to have a look at the result of all of this. And as you can see, we have a text ID, which will be important, and we will see why in a moment. Then we have some links to the subreddit, and then we have the rater ID. There are multiple people that are actually rating these. So if we go to the next couple of columns, you'll see the actual emotion categories, and there are quite a lot of those. So the first thing that you might notice is that you can cast this into a multi-label text classification problem, because as you can see, different raters can rate the same text in different using different emotions, and even a single rater can rate an emotion, a text with couple of emotions. Another thing that I'm noticing here is that the created UTC is not in a proper dateframe format, datetime format. So I'm going to fix this, and I'm going to use PD or pandas to datetime. I'm going to pass in the column, and the units, at least from what I get from this, are seconds. So this should fix the created at. And as you can see, we have some sort of dates right now. Those are not going to be important, but I still am going to have a look at these. And so the next thing that we are going to do is to check the shape or the number of examples. And as you can see, this is quite a bit larger compared to the one that we had here. So this is basically based this is basically because of the fact that multiple people are annotating the same text. So to have a look at the unique examples, I'm going to group by the ID. which should be the unique identifier of each comment. I'm going to take just the first example, and then I'm going to check for the number of examples that we have, and this number is very close to this one. I'm not sure why the discrepancies is in here, but there is some sort of discrepancy between this number and this one. Maybe a couple of more examples, I'm not sure. So the next thing that we are going to have a look at is the emotion categories. I'm going to just take their names, and you'll see why in a second. And those are basically skipping the first 9 columns, and these are all of the emotions that the annotators can do. So let's have a look at a single example from the data. And to do that, I'm going to choose a row from the data frame, let's say the 10th one, and I'm going to basically print it here. As you can see, it contains the text and all of the categories. But recall that a single annotator or a single comment can be annotated by multiple people. So I'm going to take the sample ratings for this particular comment and then print out the result. So as you can see, we have the same comment annotated by different people. And in here, we are going to check basically the different annotations that we have. So I'm going to take the ratings and just take the emotion categories or the categories from this one. And then I'm going to join the result. So let me just start with this one. So we have just the ratings using the columns. And if I do basically this, so what I want to do is to take the sum along the different columns or the different categories, and I want to filter out all of the results that are zeros basically. So this will take these. So this is a Boolean vector or filtering vector, and I'm going to take the ratings columns based on this filter, and these are the different ratings that we have for the emotions. And to get the final text from this, I'm going to apply a simple string joining, and this should give us a very nice text which contains all of the emotions that were annotated for this particular example. So let's have a look at the text of this. And of the different categories, I'm going to space out this, or the different emotions, let's say. So I have, and now that you mention it, I think that's what triggered my nostalgia. So this is joy, nervousness, realization, and neutral, according to the guys that were rating this. So this is interesting. So to do the classification, or basically any task that is related to text processing with the transformers library, we are going to use a tokenizer. And in our example, I'm going to use a tokenizer from the Electra model. And in the next couple of videos, we are going to dive just a bit deeper into what and why we're using Electra. But for now, I'm going to import the tokenizer itself, and I'm going to use the fast version, which is using Rust under the hood. So I'm going to take the model which is called Electra base discriminator, and we are going to use just the discriminator part in here. This will hopefully get a bit better to understand based on the next couple of videos and how the Electra model works. And then I'm going to use the tokenizer and load the pre-trained version of it. This will go ahead and download the tokenizer checkpoint, and basically we have the tokenizer in here. And the interface for the tokenizer is very easy to use. I'm going to just tokenize the text, and if we have a look at this, you'll see that it's a dictionary with a lot of properties. We have the input IDs, which are basically the IDs of the tokens for the tokenization, and then we have token types ID and attention mask. So let's have a bit better look at what this is. So I'm going to print the text, and then I'm going to print the tokens, and I'm going to take those from the encoding, and then the token IDs. So, yep, this is incorrect. So I'll have to use a single quote here, or let's do this. All right, let me just format this. So this is exactly the same text, and these are the tokens. The COS is a special token which says that we are doing the classification task right here. And then we have a separator token added at the end, and we have the IDs for each of those tokens right here. And this is basically a single tokenization example. One of the things that you need to do is to decide how long your sequence is going to be. And this is pretty standard stuff when you're using most of the transformers. This is a known disadvantage or weak point of the transformers. You have to basically select some prefixed sequence length, which will be handled by the model. And the models inherently have limitations of the number of tokens that they can handle at one time. So to have a look at how much tokens we are allowed to use, or what we need here, we are going to basically look through the encodings and check the number of tokens that the tokenizer is generating. To do that, I'm going to create an array, and I'm going to take the texts, the unique texts, and next I'm going to iterate over the texts, create the encoding, and then append the length of the tokens in this encoding. And we can also import GM to follow the progress. Sorry, token length, we're pending here. And this should take less than 10 seconds. And this is the number of examples that we have. So I'm going to convert this into a series, the token length, take the value counts, and sort the index, just to have a look at the largest examples. And we have an example with 316 tokens, then 115, but these are severe outliers. And as you can see there, then the number of tokens is severely dropping after that. To have a better look at this, I'm going to use the hist plot from the Seaborn library and then specify the label here on the x-axis, which is going to be the token count. And this is the result. You can see that the maybe 99.9% of the tokens are below, the number of comments has below 64 tokens. So let me limit this. So this looks very good. We can use 64 tokens for the sequences when tokenizing, and this will translate into faster training. So in the next video, we are going to continue with preparing a data module, and we are going to integrate the tokenization into our custom PyTorch dataset and wrap everything into PyTorch Lightning data module. And next, we are going to prepare a model, train using the data module that we have, do the training, evaluate, and have a look at the results. I'll see you in the next one. Bye bye.